In order to respond to climate change, the world as a whole is strengthening carbon reduction efforts, along with the declaration of carbon neutrality by major countries. In particular, the power generation sector is the core sector involved in the transition to a carbon-neutral society. With respect to power generation, the global trend is to switch to renewable energy sources such as solar, wind, and hydroelectric power. However, thermal power generation, which is centered around coal, still makes the largest contribution to the power generation sector. While the thermal power plants have the advantage of short construction periods and less location constraints, they are the cause of air pollution and a large volume of carbon emissions. As of 2021, thermal power generation accounts for 64% of the global power energy mix, making it difficult to reduce the dependence on coal for power generation. So the question is there any way to use coal in an eco-friendly manner? The Kia research team has developed a technology that considerably reduces carbon dioxide and nitrogen oxides in combustion exhaust gas, which they achieved by studying methods for clean power generation while leaving thermal power plant facilities as they are. The research team developed Korea's first ammonia mixed combustion operation technology used in a 100 kilowatt thermal circulating, fluidized bed combustion system. This technology reduced carbon dioxide and nitrogen oxide emissions by 10% and 78% respectively. Let's now take a look at what kind of technologies are utilized.
The circulating fluidized bed ammonia co-firing technology is a technology that uses ammonia fuel in the power generation field and is said to be a rare technology worldwide. This technology is expected to enable clean coal-fired power generation while securing the stability of power supply and demand, as it can reduce the generation of carbon dioxide and nitrogen compounds. Co-firing involves the mixing and burning of two or more types of fuel. More specifically, it involves burning ammonia together with coal, which is a power generation fuel. Ammonia is used as fuel in a 100 kilowatt thermal circulating fluidized bed combustion system, similar to a commercial circulating fluidized bed boiler. During circulating fluidized bed combustion, sand or fluidized sand circulates at 850 to 950 degrees Celsius to burn coal. At this point, it undergoes desulfurization and denitrification processes, making eco-friendly thermal power generation possible. Because coal is a carbon-based fuel, carbon emissions are inevitable. However, the combustion of ammonia, which contains nitrogen and can be used as fuel, does not emit carbon because ammonia is carbon-free. Therefore, when coal and ammonia are mixed and burned, it is possible to reduce carbon dioxide emissions by this difference. How can ammonia be efficiently mixed with coal? Maximizing the supply of ammonia in the high temperature region of the combustion furnace is important for the application of ammonia co-firing technology in commercial power plants. During the development process, liquid ammonia was vaporized at 40 degrees Celsius to produce a fuel. The fuel was supplied to two areas, the bottom of the combustion furnace and the piping system. Through dual combustion at an ammonia mixed combustion rate of 10.2%, the carbon dioxide content in the exhaust gas was reduced by 10% when the combustion temperature was stably maintained. Ammonia co-firing also reduces nitrogen oxide emissions. Ammonia serves as both a fuel and a reducing agent during combustion, inducing the SNCR reaction that reduces nitrogen oxides, a precursor of fine dust, to nitrogen. SNCR is a selective, non-catalytic reduction method that reduces nitrogen oxides to N2 at temperatures above 800 degrees Celsius, which is achieved via combustion without a catalyst and aims to decrease nitrogen oxide emissions. Compared to the 120.5 parts per million of nitrogen oxides emitted from general coal combustion, it was found that nitrogen oxide's emissions were reduced by 44.7% and 78.6% at 10.2% and 17.5% ammonia mixed combustion rates, respectively. This technology can significantly reduce the number of facilities and costs involved in nitrogen oxide abatement.
Kiar is striving to further develop the ammonia co-firing technology and promote its use globally. The ammonia co-firing technology allows existing coal-fired power plants to be operated in an eco-friendly manner without changing the facilities. Ammonia co-firing can be used as an alternative when fuel conversion technology for greenhouse gas reduction is needed, not only for circulating fluidized bed boilers of power generation companies, but also for private circulating fluidized bed cogeneration plants. We plan to contribute to securing the source technology by developing a basic design and operation technologies for circulating fluidized bed ammonia co-firing technology as purely domestic technologies to achieve carbon-free ammonia power generation that can simultaneously reduce greenhouse gases and nitrogen oxides. When transitioning to a carbon-neutral society, until renewable energy technology is more widely distributed, existing thermal power plants can be operated in a cleaner and more environmentally friendly manner, thereby contributing to an economical, eco-friendly, and stable power supply that favors carbon neutrality in many countries.